अंदर आ जाओ भाई. Good morning. All right, so the slides as usual are from CS 230. Okay, so we start. So today we are going to start with object detection. Okay, so what is the problem of object detection? Can any one of you tell me? What is object detection? And how is it different from classification? How many of you have used YOLO before? Okay. Alright, so we are going to discuss YOLO now, but its initial 3 versions until version 3. Later versions of YOLO have improved in many senses. Okay, so but once we go through this these basics, you will be able to relate any any new version of YOLO. Okay, so before we talk about object detection, let's talk about object localization. What problem is this? So in this whole image, you are supposed to answer just one thing, whether there is car in it or not. It doesn't have to be just a binary classification, it can be a multi-class classification as well. So this can be binary or multi-class. Now that was the classification problem. We have seen it, we have seen so many different CNNs that do this. Name a few. LXNet, then VGG 16, 19 and VGG family, and then we talked about RESTnets, we talked about Inception, okay, and so on. So classification, we more or less understand how does it work. You have an input image, you put some convolution layers, and then finally you are going to do fully connected layers and then softmax, right? That was the broad structure of everything. Now, so localization is this. So classification, you already need to know there is a car in this. With localization, you also need to put this bounding box that where is the car. Okay, this is localization. So detect, that means you have to classify which class is it, and you have to also put a bounding box around it that here it is. So this problem is called object localization, and the last one is detection. So if you have multiple objects potentially belonging to different classes, then the same problem is called object detection. Okay, so not as such, no conceptual differences, but if you come across these terms in papers or wherever, blogs, wherever, this is what it generally means. So detection means you are supposed to tell me here is the object, so you are supposed to put a bounding box and as many classes as you have defined, you have to identify all of them. So here it was only let's say cars, but if you had traffic lights in your one of the classes, then you would also output traffic lights and so on. Okay, if you also had let's say trees, then you would also try to identify trees and so on. Okay, Done? Easy? We go ahead. So then how are you going to do this? Tell me. How are you going to do classification with localization? Have a look at this figure and help me out. Yes. Have a look at this figure and let me know. So, are you doing just classification? Just classification you know how to do, right? But we also need to do. So, we need to do classification plus localization. This problem you know how to solve. What about this one? How will you make a bounding box? So, image center is always going to be somewhere here, right? It is going to be the intersection of these two diagonals. And what do I do with that center? Object ka center, but how do you know where is the object in the first place? Sorry? Masking like, देखो कम समझ में आता है, मेरे को पूरा समझाना पड़ेगा. हाँ, like masking like. And who will do all this for you? Okay. Okay. True, but how will you do it? Question is how.
सर इंटेंसिटी के हिसाब से एक वैल्यू असाइन हो जाएगी, मतलब कलर है इमेज में, और फिर उसके हिसाब से डिटेक्ट हो सकता है.
I don't get this. कैसे वापस बताओ?
इमेज में डिफरेंट कलर्स हैं, तो उस कलर के जो कोड है टेक्स्ट कोड उस हिसाब से एक टेक्स्ट में देगी.
But if you see, this car has almost the same texture as the whole image. I mean, white everywhere, so this thing can actually be mistaken as snow. So why do you assume that car's color will be different from background color?
Sir, maybe we can take some features like car will have a glass, it will have some tires.
You may not even see glasses of car if it's a top view.
कार की जैसे बॉडी है, जैसे स्ट्रेट लाइंस और उनको सिलेक्ट.
You are doing that same old thing. When we said we want to make a cat recognizer, we understood that no matter how many rules you enumerate, it does not work. Now you are telling me to enumerate rules for cars. Now cars can be different sizes, different brands, different variations. So we are not here to make rule based systems. See, deep learning and rules based things, as of now, as of today, they don't go together. Okay. So if you are doing deep learning, write this down. Your goal is to do it for end to end learning. Okay, so if you are doing deep learning, it's a bad slide to write this thing because, but anyway. So when you want to do deep learning, you are doing end to end learning. So you need to prepare your data set. Until now, when you were doing classification, how were you preparing your data set? Tell me your data set. Tell me example of your one training data set. Sorry, one training example. How was one training example looking like? How was one training example looking like? Yes. ये तो गड़बड़ है. How was one training example looking like? So if I have examples from ImageNet, I have millions of images, I have 1000 classes. How will my one training example look like? So there was exactly one class. In ImageNet you couldn't have more than one class in an image, right? You had to tell which class is it. But is that different from localization and object detection? In object detection, given one image, you might output multiple classes as well, okay? But as of now, we don't know how to do it. And important here is you have to put a bounding box that here it is. So I don't just recognize that there is some class in this, I have to also tell where is it. So how was the example in ImageNet looking like? Okay, tell me how was an example prepared in MNIST? So you have an input size 28 cross 28 image, whatever, 28 cross 28, 32 cross 32, whatever it is, okay? And now, so let's say there is digit 2 in this. What will be its label? Awesome. What will be its label? Done? Right? There will be 1 at place 2. So this will be 0, 1, 2. There is 2 in this, so 1 here, 0 everywhere else. So if you have 1000 classes, what will happen? In this image, if there is a car, okay, then what will happen? Whichever one you have chosen for car, it will be a 1000 cross 1 vector because there are 1000 classes and there will be 1 at exactly 1 and for everywhere else it will be 0. So what will your deep learning algorithm do? Take this as input and try to match this with the output. Then it's a very good question to ask, how will you compute loss, even though we have done all of it in the class. How will you compute loss? In this case, first, so this is your ground truth. What will be you predicting? You will be predicting something like P0, P1, P2 all the way until P9. Of course, summation Pi equal to 1. If P2 is the highest, you declare this is fine. So this is not max in that sense, because otherwise you would like to keep this 1. This is soft max, okay. So these two guys will multiply and log of P2 will remain everywhere, it will be 0. So this is my loss on one example. How will you do it for ImageNet dataset? Same thing. Instead of 10 classes here, you will have 1000, otherwise structure is the same. Okay. We go back. What do I do in this case now? How do I solve this problem of localization? you need to be, present here mentally in this case now. Object detection, it requires lot of preparation before you start training. So you have to prepare your training data set. If you don't prepare your training data set, it will be hard to use deep learning to do it. Because the problem that you are posing is very vague. So somehow you will have to bring this thing in your training. How will you do that? How many of you were using Facebook between 2010 to 2014-15? I don't expect you to, so don't raise your hands. Yes. All right. So, see, those days what Facebook was doing was, so let's say I uploaded a picture, right? 3 of us are there, 3 friends, whatever. Now, Facebook will prompt, are there persons in this image? Okay. So, it will also give you a bounding box. You will drag it over the faces. And then it will say, would you like to tag your friend who is in your friend list? And then you will go and tag. What are you actually doing? So all of us were preparing data for Facebook, right? If they have a team that prepares this data, it will take enormous amount of time because there are billions of images. So you can't have a team that does this. You give this task to every fool on the internet and they'll happily do it. Okay? So that's what we did. So this is how exactly you will do it now. We will come to face recognition in the later classes. Right now what we are saying, we are supposed to figure out where is the car in this. You can't do that. Okay? So you will have to prepare training data set accordingly. So this is your input image. This is your output. You have to help me prepare output first. How will the output look like? You can read things here. So how many classes do I have for this example sake? You have 4 classes, okay, and this is basically exhaustive because you have 4th class as background. So even if none of these things is there, background will still be there. So this is exhaustive. Okay. Now you have 4 classes. So if you were just doing classification, what will you do? Input image, pass it through a convolution network, and then finally you will have 4 neurons in the output. You will do softmax there and done. Okay. Is that enough for localization? No, you need more. What do you need? Bounding box. So you have softmax of size 4, this one. But you also need to give me coordinates of bx, by, bh, bw, which is the bounding box. And you will have to do this while preparing your training data set. So this is your bw, this is your bh, okay. This is width is bw, this is b height, bx, by, bh, bw. What does it give me? So what is bx and what is by, what is bh and what is bw? If I have to fix this uniquely, if I have to fix this bounding box uniquely, what are needed? What do I need? If you give me these 4 corners, am I done? Or those 4 corners, they don't really represent this bounding box uniquely, do they? Once you fix these corners, it's a unique bounding box, right? Or can you have something else? Right? But how many coordinates you need to store in this case? So 4, and each one is in R2. Okay? So right. So 8, even though there are repetitions, because this guy will have same x coordinate, same x coordinate, same y coordinate, same y coordinate. So how many unique coordinates do you have? 4. That means you should be able to reduce down the number of variables that you require to uniquely fix this from 8 to 4. So you have this center coordinate, okay, and then you also tell what is BH and BW. Will you uniquely fix this? Just think over it. You have fixed the center, so center is your BX, BY, and then BW and BH, and that fixes this particular bounding box uniquely for you. Okay. Right now we are using everything that is in rectangular shape. You are talking about 2015 when this problem was not at all attacked on, right? People were just solving classification. So then you have your convolution network, whatever it is. How does my output now look like? Apart from the classes, I also have these 4 numbers. So what is the size of my output? It's a vector of size 8 cross 1. If I were just doing classification, this would be a vector of size 4 cross 1. But in this case, it becomes 8 cross 1. Any questions? Any questions in this particular figure, in this slide?
जो ऑब्जेक्ट आउटपुट में आया उसके जो कोऑर्डिनेट्स हैं वो आउटपुट वेक्टर में नीचे 4 क्रॉस 1 में होंगे.
So what will be here in this case now? Bx, by, I need 2 coordinates for this point, and also bh and bw. Is this part clear? Box can be tilted or not, you answer. So we are not doing that right now. Okay, our box will be just like as it is. So this line will be parallel to your this line and so on. If the car is tilted, so let's say if the car is like this, you would still make a bounding box like this. Okay. Remember, you are solving a problem which nobody attacked before. So right now we don't want to solve it in its entirety. Okay, we just want to get hold of how to solve this problem. That's it. More questions here? Wheels? Huh. So image is your input, okay, and your output will be C1, C2, C3, C4, Bx, By, Bh, Bw. This is how will your output vector look like. So here no Bh, Bw per se. Yes, more questions? Ask as many questions as you can, because later this will help us. Yes. Sure. So we have prepared training data set for this one. How will you prepare this training data set? If you are given millions of images, just to look at and write down which class is it, it's a big deal. Now you are supposed to put a bounding box. How will you do it? Initially, how are you supposed to do it? Exact same thing that I talked about Facebook, right? You can't make a team that does this. You have to crowdsource it. So either you pay the crowd or you make it interesting enough for crowd to do it. Okay. So let's say now you have hired or crowd or whatever. You have got now millions of images that don't just have images and their classes known, that also has a bounding box. It's a very laborious task, right, to create data sets in deep learning. So all this, success that we are seeing, if you go behind the scenes, there is a lot of data engineering. So how do you create these kind of bounding boxes for millions of images? That's a big deal. And none other than companies like Meta, Facebook, they could do it because nobody has access to that many images. Initially, ImageNet was a very good data set to work on, but later once the industry, overtook the academia is, and in the academia right now is absolutely not at all at par with industry in terms of performances on this. They might come up with something new, they might come up with the theory of deep learning and hence better models maybe, but as of now, any given day, industry beats academia in terms of compute, in terms of the resources, the other resources that they have, and so on. So you know how to prepare this data set now. How will you actually do it is not a matter of concern for our class. What we are saying, this is what I need, and somehow magically I will have millions of images that have this property. Okay. So if it were just classification, my output will look like 4 cross 1, C1, C2, C3, C4. I have classification with localization, my input will look like C1, C2, C3, C4 and BX, BY, BH, BW, and I somehow have these numbers for all my images. Now defining the target label Y, we have already done this. So this is fine, right. So we need to output BX, BY, BH, BW and class labels. So our algorithm is not just supposed to output class labels now, it is also supposed to output BX, BY, BH, BW. So if this is the input, tell me how will your output label look like? मेरे को मत देखो भाई, इधर देखो and tell me. Question is, if this is the input image, how will my output label look like? Right. So label 1 is for pedestrian, 2 is for car, 3 is for motorcycle. So you have only C1, C2, C3 here. Okay. You have to help me out figure out why not C4. This is for the bounding box. Okay. What is this guy? Is there any object? Okay. We'll come to the loss function in a minute. So what is the label for this guy? Is there an object in this? Let's say if this was not car but a bicycle, then what happens? There is no motorcycle. C1, C2, C3 only.
All three are 0, then there is object but background is there.
So we are doing that same thing. What we are saying is that first bit of my output is 0 1. Okay, PC is 1 if there is an object. And what is the definition of my object? It has to be one of the classes. It can't be anything that I look and decide this is an object. No, it has to be one of my classes. Okay, except background, others kind of class, PC. And now this is the bounding box. This is the, which is the class of the object. So you have to explain me now the cycle will not be detected as a class because it is not there in my list of classes. Okay?
ऑब्जेक्ट
हाँ,
तो ऑब्जेक्ट के लिए और जो चार कोऑर्डिनेट्स हैं वो जो ऑब्जेक्ट डिटेक्ट किया उसके
right,
और जो जीरो है वो C1 के लिए यहाँ पेडिस्ट्रियन है नहीं
बिल्कुल,
C2 कार है तो
exactly, right. So why do you have this one here? Because there is an object that belongs to this class. Okay, so you have that one here. This Bx, this guy is bounding box. And then we have C1, C2, C3. Why I don't need background?
by default तीनों classes हैं तो
Okay, you answer label for this one. PC is, so this first bit is PC. That means probability of a class. So probability of a class is 0. What are these question marks? If there is no class, I don't care what are these values. Okay, because if, see, in the end you will have to label, in the end you will have to put numbers, but these numbers make sense only when PC is 1. If PC is 0, these numbers will certainly be something, but I don't care what are they. So this PC is a super important bit now. PC makes a mistake, everything else will be at stake. Yes, questions here, more questions. So right now we are just taking one image and we are trying to localize it. If you try to localize multiple images, that problem is called object detection. I just don't care. If you always start fixing 0, exactly, that's what I am saying. These numbers can be anything and I just won't look at them in whatever sense. Okay, so let's put it from the perspective of the labeler. You are labeling these things. If there is no image here, you put a 0 here and you don't care what is the rest. Don't even look at what are the numbers here, because eventually in computer's memory something will be there, right? In computer's memory you can't say question marks, you can't say I don't care. Some values will be there, but I just don't care as long as this is 0. More questions? I don't get this.
So like first it is PC and then we have bounding box and then we have classes. So
You tell me, can I change the order? So can it be so that for one example order is this, for another example order is something else? No, right? These order, it does not matter which order do you fix in, but once you fix it, it gets fixed. And PC seems to be so important that it makes sense to put it here. Okay, But as far as these things are concerned, up to you. You want to keep C1, C2, C3 here, I mean do whichever way you want. You want C1 here, then Bx, then C2, then By, up to you. But once you fix an order for this, it has to be strictly followed for all the examples, be it millions in your training data set. More questions here? Okay? Okay, no, not okay. Now, once you have created a label, which is Y, not Y head but Y, which is also known as the ground truth. Once you have fixed Y, we are in a position to also talk about loss function. So, my loss function will be a function of, my loss will be a function of Y hat and Y. Why I now know? Whatever Y hat I have, assume whatever Y hat you have, how will you compute loss function? How will you compute loss function? It is here in front of you. Yes. Once you know how to label Y. So once we are done with this Y, remember until now we had not done much with this Y. We knew what Y will be. Either it was 0 or it was 1 or it was a vector in which there is exactly 1 and everywhere else you have 0. This is the most complicated Y we had prepared. But now the complexity of Y's are increasing. That means the cost of labeling, the human labor cost of labeling these images is going to get up. Okay. So you have Y here, Y hat, whatever Y hat is, it will be a vector of size 8 cross 1 for this example. My question is, how do I write my loss function? So here you have Y1, that means the first element, square. So Y basically, let's say if for the sake of this one, if you write Y1, Y2 all the way until Y8, this is my label, and let's say correspondingly I have Y1 hat, Y2 hat, Y8 hat. So this is Y label, this is alright. So this is Y, this is Y hat, and these are the corresponding values from Y1 to Y8. Okay, we are not calling them for the sake of this argument, PC and so on. So tell me, how will my loss function look like? Difference, is that it? Is that enough? See, you can keep this whatever you say, you have to argue in favor of that. Sorry? Okay, so we need to do square or not? So, करना चाहिए, okay. So here you have squares. What else? So first of all, let's talk about what is written here. It is simply so this is same. This looks like linear regression, right? Mean squared error. So y1 the ground truth and your prediction. Take the difference and square, because you don't know in which direction is this difference taking you, and you do this for all the 8 quantities. So y1 minus y1 hat squared, and you write it for all of them. If y1 equal to 1, why do we have this? If this guy is 1, I care about rest of the things. So if this guy is 1, then it is this. Else just the square of difference of the first element, because I don't care about what is there in the rest of the 7 things. Do you like this loss function, or can you help me improve it? You can. Yes. What is the problem with this loss function? Where will mean square error make sense if you look at this? Mean square error was for which algorithm? Linear regression. In linear regression you output real values. Okay. So where are the real values in this case? These guys are real. What about these things? They are classification outputs, and for classification you had cross entropy, right? So it will make much more sense if you take those things into account and not just this, because C1, C2, C3, right, they are better modeled in cross entropy terms than linear regression. So while this is okay to start with, eventually you will have to come up with a better loss function. Any questions in this particular slide now? Yes. So now we talk about landmark detection. Now similarly, like you had bounding box here, for faces you will have a lot more. If I am not mistaken, how many do you have for faces? So you have 64 landmarks. Okay. Labeling this is going to be a tedious task again. Okay. So what about this one? Which problem you are solving maybe? Right? Usually post detection kind of things. Okay. So you everywhere have these landmarks, and all these guys are going to be real values, and preparing data set, preparing training data set for all these things is a big deal. So now we come to object detection. How do we solve this problem now? Yes. You don't have just one object anymore, you can have as many objects as you want, but they all should belong to your classes. Anything outside the class is not my object but belongs to background. Okay. So for example, roads and trees here, if they are not part of my classes, then they belong to background. But let's say again, if traffic lights are, then I am supposed to detect and put a bounding box against them as well. So how do you prepare training data set now? What is happening here? X is my input now. What happens if I input a car? Output is 1. Car output is 1, 1. Background 0, background 0. So for car it is 1, for no car it is 0. And what is happening here? We know how to prepare a convolutional neural net such that given this image it will tell me whether there is car in this or not. That same good old classification problem. This will start in the next class. But can you just give me a vague idea of what is happening here? If you see, all these images are very much cropped. These images are only as big as this car fits. All these bounding boxes are square bounding boxes because else bounding box for this could have been trimmed here. Okay. Similarly, maybe for this one here and here and so on. Okay. But the more precise bounding box you want to create, you need to pay more to your users in whatever sense. It will take more time for them to do this. Okay. So tell me what is happening here. So sliding windows, how does it work? You put your sliding window here. Okay. This you can answer actually. And I am looking for this car. What will I do? Keep sliding this everywhere. Okay. At some point I hope that I will reach here and there is a car. So I will say yes in this case. And where is the bounding box? Where is the bounding box? The sliding window itself, right? This window itself will be the bounding box. Hopefully it will also occur somewhere here and this car will also be detected. What is the problem with this? What is the problem with this sliding window approach? Size of bounding box is a problem, right? In this case, if you see, bounding box was smaller, it may miss cars that are bigger, right? What happens if you take bigger bounding boxes? It will create problems for that are smaller objects. If you take just too big, and in the limit you can take this is as big as your image itself, right? And this can be as short as your pixel itself. So if you look at meta papers these days where algorithms like segment anything and on, they actually assign labels to every pixel. Okay. Anyway, but that's it for today.